Hello, everyone. My name is Jamie Delbick, and I will be demoing how to customize asset processing in AEM assets as a cloud service using Project Firefly. A little background about myself first. I have been with Adobe for almost 2.5 years now, working on AEM assets as a cloud service, specifically on the Asset Compute service, which you will hear more about today. Before Adobe, I was in college at UC Berkeley. Go Bears, if there's any Berkeley fans out there. So to start, I will just give a brief background on AEM and extensibility before going into the demo. Also, remember that you can double click on the screen that is showing the PowerPoint in the session to zoom in. That way that's bigger and my face isn't taking up half of your screen. And also I have Alex from my team here monitoring and answering questions in the chat pod. So thanks, Alex. All right, so let's just, okay, so to start, in case you don't already know, AEM Assets as a cloud service is a cloud-native platform as a service solution for experience management. This helps businesses perform their digital asset management and dynamic media operations with speed and impact. It also easily integrates with AI and machine learning tools. It optimizes marketer and developer workflows for the entire content lifecycle, informed by data insights. And as you can see, here is a photo of what the typical UI might look like in AEM assets. And to the right is also an example of a processing profile, and that's how you can configure custom processing of renditions, and there'll be more on that soon. Okay. So if you knew AEM before, we recently moved to the cloud. And why we moved to the cloud? Well, for one, it's always on. 2, it's always current, which means it's versionless. There's automated rolling product updates. 3, it's always at scale. There's auto scaling and microservices for asset ingestion and processing. And lastly, it's always learning. With data, engineering teams are able to track global performance and perform automated corrective updates. So in summary, we use the move to the cloud to leverage cloud native features for binary delivery and upload in cloud scale processing. Some of the changes are asset binaries no longer live in the AEM instance. AEM only coordinates access to the Azure Blob storage where the binaries are stored and sends requests to Asset Compute for processing. Some of the perks of these new features are, well, for direct binary access, it minimizes the load on networks and duplication of binaries stored. And for the asset microservices being externalized, it saves resources like CPU and memory. Another perk of the Asset Compute service being externalized is it's extendable, easily extendable, which is what this demo will focus on. That was just a small background about AEM assets as a cloud service, but if you do want a deeper look, I encourage you to go and read the public documentation for more information. Okay. So now, as I mentioned, this demo will focus on extending the Asset Compute service or the asset microservices. But what is the Asset Compute service? Well, it is a scalable, lightweight, and extensible cloud service for processing assets for AEM, and it runs completely on Adobe Aio runtime. It can handle many file formats and convert them into different renditions like thumbnails, extracted text, metadata, and more. Okay. So just to give you more background on how the Asset Compute service works with AEM assets, first someone will upload an asset to AEM, and the binary is uploaded directly to cloud storage. After the upload completes, AEM sends a processing request to the Asset Compute service. The Asset Compute service then distributes the job to the necessary worker. These workers can be Adobe built-in workers or a custom worker. And these custom workers can call other Adobe services or third-party services, but they are all serverless functions running on Adobe Aio runtime. Inside the worker, it will take care of downloading the source file directly from cloud storage, processing the rendition, and then uploading the processed rendition to its specified cloud storage location. After the worker finishes processing and uploading the rendition to cloud storage, the Asset Compute service will generate an asynchronous event via the Adobe Aio Events service. Since these events are asynchronous, the client AEM assets will be polling the Adobe Aio Events journal to get the status of the asset compute processing. Once AEM is notified via events that the processing is complete, along with direct pointers to the generated binaries or renditions, the renditions are available in the Experience Manager UI for the uploaded asset. Okay, sorry. So as mentioned before, these workers that the Asset Compute service uses can be built-in Adobe workers or your own or custom workers. And these custom workers are custom asset applications for use cases such as calling external APIs to perform image operations or leveraging other Adobe services and APIs like Adobe Sensei. These custom workers are all Project Firefly headless apps written in Node.js. In case you didn't attend the Project Firefly session earlier today, or you are not already familiar with Project Firefly, it is a framework to build and deploy custom web applications on Adobe I/O runtime to extend Adobe Experience Cloud solutions. To create custom applications, the developers can leverage React Spectrum, which is Adobe's UI toolkit, create microservices, create custom events, and orchestrate APIs. Again, if you're not familiar with Project Firefly, I just gave a quick summary, but I encourage you to go and read their public documentation to find out more. So as mentioned before, our custom workers are just Firefly apps deployed in a third-party I/O runtime namespace. So they actually function the same way in the asset lifecycle as our built-in workers, except, well, not except, but all of the workers, our built-in ones and custom workers, leverage our Asset Compute SDK for downloading, uploading, and sending I/O events. So basically, all the custom worker needs to do is actually process the rendition using their custom tools or APIs that you would like your custom worker to use. So we make it really easy. There's lots of libraries to help out. Basically, so inside the worker, you only deal with local copies of the source file and produce a local copy of the rendition. And then the Asset Compute SDK will deal with uploading and downloading it from blob storage, as well as sending the I/O event to let the client know that the asset has completed processing. After the custom worker, so also since these custom workers are Firefly apps, we leverage Firefly's developer tools and extend some of them to fit our own needs for custom workers. These tools help with writing, testing, and deploying custom workers. Finally, after you have deployed your custom worker, the URL can be used in a custom processing profile in the AEM instance. And that is how then after that is configured, when an asset is uploaded to AEM and AEM sends the request to Asset Compute service, it will call your custom worker. Okay, so next I will be demoing how to create a custom worker, run, test, and deploy it, as well as also using it in AEM. A few things before developing a custom worker that you need to be a part of an Adobe Experience Cloud organization that has AEM as a cloud service enabled. It's also, this organization must be onboarded to Project Firefly. Additionally, for this demo, you will need access to Azure Blob Storage or AWS S3. The free tier is good enough. It's basically so you can utilize our developer tool which helps with testing and debugging your custom worker. And the last thing that you need specifically for this demo is access to the Content and Commerce AI in the Adobe Developer Console. That is because the APIs that I will be using today in the custom worker are those APIs. The tools I will be using today are Node.js, the AIO CLI, Docker Desktop, and VS Code. Okay, so also, before I begin the demo, I actually already created a Firefly project. This is strictly just so I don't have to display my credentials to you on the screen. So I ahead of time created a project from a Firefly template and added some workspaces. If you watched the Firefly session in the morning, they actually walked through exactly how to do this. But if you did not, there's plenty of documentation out there and step-by-step going through how to set up a project Firefly on the Adobe Developer Console. Also, I added the necessary APIs already to the workspace I will be using today. The necessary APIs for an asset compute custom worker are the following: asset compute, Aio events management, and then for this demo specifically, the content and commerce AI API. Again, I just listed those out now, but we have documentation that goes through step-by-step how to add these APIs to your project, as well as what to do with the credentials and how to set up the credentials file for the custom worker. That is the other thing I won't be going through in the demo today, strictly just because I don't want you guys to see my credentials on the screen. But we have plenty of walkthroughs as well as documentation going through this step-by-step. Okay, so that's a little preview of what the demo will show, but I think now it's time to begin the demo. Okay, so again, as mentioned, the APIs I will be using today in the demo are the keyword extraction API. I will be using this to do a PDF extract tool. And then also, it's kind of a cool tool. It will find like these named entities inside by looking at a file. And in the use case I'm going to use today, it's going to be a PDF file. The other API I will be calling today is the Ccai color extraction tool. This is kind of cool. It picks out the colors that are in a file and how many and the percentage of each color that's in the file. So this is really cool too. I encourage you to go here and read more about these APIs. Yep, okay. So now the first thing I'm going to do is run the Aio App Init command. And what this will do is hopefully, so I already logged in ahead of time, but if you did not, it will prompt a browser screen to open up and you have to log in to the Adobe Developer Console. I already did that ahead of time, so it just showed up here for me. But then after that, you will get to this screen, and I'm going to go ahead and choose the org. I'm going to be working in the Firefly project that I'm going to be using, and the workspace. I'm going to be using this Delbick workspace for the demo. And what this command does now is it's going to initiate a skeleton of a Firefly application. And it also gives you options of what you would need for in terms of a asset compute custom worker. The only things we need are actually just the action. So you can go ahead and uncheck everything else. And then here we're going to choose the Adobe Asset Compute Worker. This is able to show up because my Firefly project that I chose in the workspace has access to the Asset Compute API. So that's how this is able to come up here, and I'm able to choose Adobe Asset Compute Worker as my skeleton. And we're going to call the first worker Ccai PDF extract. Okay. Now what this is doing is creating all the files for a Firefly application, as well as installing some of the custom tools that come with creating an asset compute worker, like our Asset Compute SDK and our plugin to the Adobe CLI, which will help us to use our custom developer tool and testing framework. Okay, so pretty quick, created the app in demo here, and we can look, that seems to be right, has most of the features we were expecting. I don't know if you're familiar with Firefly applications or not, but I'm going to go ahead and open this up in VS Code. All right. Oh, I think I opened up, oops, I opened up a file. I was already in this. Okay, we can go ahead and delete that. Okay, so here is the normal structure of a Firefly application. I'm not going to go through in great detail, step by step, what each of these files are or mean, but I encourage you to look at the Firefly application or at the Firefly documentation about Firefly applications to understand more deeply what each of these files are and mean. But pretty quickly, I'll just take a look at the package JSON. This here already installed our ACID Compute SDK, which, as mentioned, is very helpful for creating ACID Compute workers, as well as also it installed our custom plugin to the CLI, which I will use some commands, some of those commands today while developing. Okay, the other interesting thing to note is the manifest YAML. This is the file that tells runtime what to deploy. So you can see it's linked here to our action, and now we know where to find our action code. Again, there's some credentials files here like .env, which is not to be committed to Git. Very important. I'm not going to show this also because it contains some credentials, but we'll just continue on. Here is some sample tests that come with the ACID Compute template. We have a really cool test framework. I'm actually not going to go too much into the test framework today, but as mentioned, we have plenty of documentation on it. We make it so it's pretty easy to just set up test cases where you really only need a file, the expected rendition, and then a params file. So super easy to use. Definitely encourage you to look more into that if you're curious. But now I'm going to go to the worker code, and this is basically the skeleton template worker that you get when you run the Aio App Init with and choose the ACID Compute worker. So as you can see, it uses our ACID Compute SDK and uses specifically the worker API. What this worker API does is it will download the source file for you, and that source file will be available in source.path, and then it will invoke this asynchronous rendition callback function that you define. And this is where the worker processing really happens. So all you need to do in your custom worker is define this rendition callback function. And what the rendition callback function has to do, the least it has to do is write something to the rendition.path. This is the local location of your rendition, which then the SDK will upload to the specified cloud storage location. So as you can see, this is the simplest example possible. It just copies the source file to the rendition file. So if we were to deploy this worker, which I'm not because it doesn't do anything that interesting, it would just take a source file and produce a rendition that is the source file. Okay, so now I'm going to go ahead and add in the code that calls PDF extract API and also the code that calls the color extract API. So it's actually going to be two workers, and I'm going to go ahead and copy that code as well as copy in my environment file credentials. So we can just do, we'll copy this, and then we have to make dir, making a new folder for the color extract action, and then also we'll copy in the color extract action, and then we'll also copy the .env file. Again, I just copied in the .env file. This is just so I don't show my credentials on the screen, but we have plenty of documentation that goes over how to set that up. One important thing to note is the .env file does include a few custom things you have to set for ACID Compute workers. Those are, one is the path to the private key. This is so our developer tool can actually invoke your worker and or can actually format a request to send to ACID Compute. And then also the other thing that is needed is cloud storage credentials, either Azure or S3. I mentioned this before. Again, that is for also the developer tool so that it can format requests with pre-sign, put URLs, and or pre-sign, get URLs, and pre-sign, put URLs for the source and rendition file. Okay, so now let's quickly take a look at the two workers that I just added in here. So the first one is the PDF extract worker. And also, just to point out, all this code that I just copied in here is online, so you can take a look at it after this. So I'm not going to go through very deeply what all this code does. So definitely go take a look at it after or during if I'm boring while I'm speaking. I don't know. Yeah, so basically what this code does, there's some helper functions above, but if we really just go down to the worker API being called here with our rendition callback. So basically what we do is we just format the request for the API, again, using the endpoint and the analyzer ID. We format the request, add in our credentials so that we can actually invoke this, so we can send a request to this API. And then we just do an HTTP post request to the API, as you can see here, pretty simple. And then we parse the response because it kind of gives back a long JSON response. So we parse that into something more readable and then format it into an XMP file. And then we go ahead and write it to an XMP file. So the rendition we produce is an XMP file, which will then be written as metadata to the file or the asset in AEM. So that's why we're writing it to an XMP file here. Yep, so the the color extract worker pretty much looks the same as the PDF extract, except it calls a different service. It calls the color extract service instead of the keyword extract service, but same endpoint actually. So you could combine these into two workers pretty easily if you wanted to. And then a little different parsing, but if we just scroll down, sorry, I'm scrolling a bit fast. If we do just scroll down to the bottom here, the worker API call with the rendition callback is pretty much the same, just with different parameters since it's a different API request. Okay, so now there is two more things I have to do. One, these workers use two libraries that don't already come installed, so I'm going to go ahead and install those. And then the second thing I have to do is we added a new action, so we must add it to our manifest YAML. So pretty easy to add a new action. You can just create a new folder and then just add that to the manifest YAML. Pretty easy to do. I think AIO has an add action command that you can use to even simplify the process even more. Okay, so now both of our workers are ready, and let's go ahead and test it out in our developer tool. So the command for that is Aio App Run. What this will do actually is deploy our actions to the namespace that's defined in the .env file here. Since I logged in, I created this app. I didn't even have to enter in my credentials in the .env file. They will just already be there added for you. That's a nice perk of logging in when you are creating an application. So this takes a minute to start up. But what it should do, it should prompt a browser to open up, which will hopefully be here and not the browser I have open in the other screen. Oh, okay, perfect. So now this is our developer tool. It's pretty easy to use. It already actually formed requests for us that we could call, which is really cool because it recognized we had two workers there. So there's really not much we have to do to even just test a sample request to our ACID compute worker. So a few things to note. I mentioned you need S3 or Azure Blob Storage credentials to use the developer tool. That is so you can have access to a bucket or cloud storage to use in requests here. So yes, unfortunately, you do need to have access to S3 or Azure. That is a requirement of using the dev tool. but it is not a requirement for like deploying the action or the custom worker. So if need be, like you didn't have to, this isn't mandatory. It just helps with the development process. Yeah, so we'll go ahead. You can see the URL that they formed here. So there's two, since we have two workers, CCA PDF extract and CCA color extract. So let's first go ahead and just run our PDF extract tool. So we're going to need a PDF for that. Let's see here. Should have some in this bucket. Okay, we'll use this one. So you can also get like a nice preview of what the asset you're going to be using, which is kind of cool. So you can see it's this PDF about AEM assets, which is what this is about. So, okay, the one other thing you have to change is, as mentioned, our rendition is an XMP rendition. So you just have to change that there. And then we just press run, and hopefully it should produce a rendition to the right here. But first we can take a look. This is actually the request. So all you had to do was enter in like the rendition object here, but it would be nice to know what the actual request looks like. So that is here, which is nice just for debugging purposes if you did want to run a curl command or use this in Postman to run some sample requests. So as you can see here, the developer tool pre-signs the URL of the source file, which is really nice because that's kind of an annoying manual task to do while testing. So also it produces the pre-signed put URL for the rendition, as well as just formatting the request into the way Asset Compute understands it. And then also we have the response here. So this activation ID is really useful because it's the unique identifier for this action invocation. So for your custom worker, so you can like use this to access the logs. But actually we already, or the action sequence, actually, I mean, this, basically though, we have here the logs for you in the UI, so you don't even need to go ahead and use like Aio App logs to find the logs. We actually just put them here in the UI for you. So this is kind of nice when debugging. You can just see the activation logs here. And as you can see, a lot of these logs are actually from our SDK, like download finished, since the SDK takes care of most of that. But you can see some of our custom logs here, like using Analyzer, as you can see, and using endpoint. So it's really nice for debugging. You can just add some console logs and they'll show up here as you're testing out your worker. Okay, let's take a look at the rendition. So this looks pretty good. As you can see, it identified some organizations. You know, it's not perfect. I don't know if renditions are really an organization, but Adobe Systems is, so that's cool. You know, you can look through and kind of determine which ones fit or not, but it's just nice to just have this for you as options. So looks like it worked as expected. We'll go ahead now and try out the color extract tool. So we'll just need to change that. So now we're calling our color extract tool, and let's choose a different photo for that. Okay, we'll choose this elephant photo. So what this worker is going to do is it's going to call the CCA color extract API, which will figure out which colors are in this photo. So we'll probably get a lot of like brown and gray and some yellow maybe, and a lot of white from the sky too that it will figure out is in the photo. Cool, so again, we can see the request here as before. Then also the activation logs, which, yeah, sometimes the activation logs are not going to show up in the UI, which is actually a good thing that happened because I can show you the other way that you can access these logs. But first, let's take a look at the rendition. So as you can see, it did identify the colors in the photo pretty well and pretty specific too, like olive as the color, mustard. Yeah, I mean, looks pretty good. So now we know our worker is working as expected, and we can go ahead and deploy it and then use it in AEM. So we'll go back to the worker. So here we can just stop the dev tool by doing Command C. So as mentioned, the logs will also show up in the terminal. Looks like there was maybe an issue getting the logs for the past activation ID, which does happen. So usually just rerun the request and the logs will be there. Yep, okay, so now we're happy with our actions and we're gonna deploy it. Okay. As mentioned before, Aio App Run does deploy the actions for you already, but I'm just showing this command just in case you did make some more changes and then we're ready to deploy it. This will deploy it to the namespace and to the namespace that I have defined in my .env file, which is the namespace in my workspace Delbick in my Firefly project. As you can see, it has, this is probably pretty small. Let me increase this bit for you guys. As you can see, it has the Delbick here. But if you did want to deploy this to, say, stage or production or some other namespace or workspace, I mean, you would have to change the credentials, the namespace authorization credentials in your .env file before deploying. So that's just something to note. Now we have these two URLs for our workers, and we can go ahead and put them into a custom processing profile in AEM. So let's go ahead and do that. Okay, so here is AEM. I don't know if you guys are familiar with it or not, but it's pretty simple to just set up a processing profile, especially one for metadata renditions. So we'll go to Assets, Processing Profiles. We'll create a new processing profile here. Let's call it Ccai PDF extract. Oh, yeah. Profile, okay. Oh, okay. So this is going to be a custom processing profile, so make sure you check the custom tab. Then we'll create new. This is going to be a metadata rendition. And you see here, we just have to enter the endpoint, which was displayed for us when we ran Aio App Deploy. So I just copied and pasted that from the terminal. As you can see, there's this little note here that it must be a Firefly app from the same organization as your AEM instance. So that's important to remember. So also for this PDF extract tool, we only want to examine PDFs. So we'll just go ahead and add that there. And then we can just click Save. And then we'll go ahead and apply that to our Adobe Developers Live demo folder. Now let's just create the processing profile. Sorry, this is a bit repetitive, but we'll create the processing profile for the color extract worker that we created. So add new metadata. Let's go back and copy the URL. Again, the Aio App Deploy command deploys your actions and then displays these URLs for you to copy here. So that is where I'm getting that from. Enter the endpoint. And this one is going to work on image assets, so looks good. Okay, then we click Save. We will apply this to the same folder. Again, sorry, this is a little repetitive here. Cool, so now that both of these are set on our Adobe Developers folder, we can go ahead and upload some assets and see the results. Okay, I'm looking at the time, realizing should probably hurry so we have some time for questions. So I'll go ahead and upload some assets quickly and hopefully then we'll see. So the first one I'm going to upload is a PDF. It has, sorry, this is small and hard to see, but this basically has some images of like mountains and skiing and that kind of stuff. So we'll expect the PDF extract tool to find keywords that have to do with mountains and such. And then we'll also do this snowy mountain glacier, lava rock. We'll just upload all of these. Okay. So I encourage you, if you do have questions, ask them in the chat because we will be running a little bit. The session ends at 1:45, so make sure to ask your questions now if you do have them, because I'm not sure how much time we'll have for questions after. Okay. So now, as mentioned in the slideshow, what is happening now is these assets are being uploaded directly to cloud storage. After that upload is complete, AEM will send a processing request to the asset compute service. The processing request will include our custom processing profile configuration that calls our custom workers. So that is how the asset compute service will know to invoke our custom workers, and then our custom workers will do their magic and send an event back to AEM when it is done, and hopefully our renditions will be available in Experience Manager. Since these are metadata renditions, the way that we can look at them will be by analyzing the metadata. So I'll go ahead and refresh, see if any of these have completed yet. They sometimes take a little while. They all have the new badge. So let's see, let's make sure they hopefully did what we do want them to do. We'll see. So I went ahead and configured a content and commerce AI like metadata section here, but you can configure that yourself. Looks like the metadata is missing. So maybe something went wrong with our worker, or it didn't call our worker. So one way we can check that is the CRXDE. We can look at our assets and see if it did call our worker. So looks like it just did not call our worker. So we'll go ahead and just try to reprocess that. Sometimes the applying to the folders doesn't totally work, so we'll just have to try it again. Okay. Then I assume these ones also had the same issue, but we can try and take a look. Okay, so this one worked. As you can see, it called the color extract tool, and we can see it did a pretty good job of defining the colors. So this is pretty cool because now we just have this information in here. You can, adjust it or move some to the top, but it is sorted by like the amount that is in the photo. So this is pretty cool. Now we can search things like light blue, and this photo will come up. So, or even specifically like 50% of the photo, at least light blue, and this photo will come up. So that's super helpful, especially when you have a really big like AEM assets collection of files in here. So this is super helpful to have this information in there. And we didn't even need to go and look at the image and apply it ourselves. We just had to call the lovely Content and Commerce AI API with our custom worker. So now let's go ahead and see if maybe the PDF extract tool worked. It is a demo, so it probably didn't. I'm kidding. Looks like something might be happening. Let me try again. Maybe I configured the processing profile incorrectly. We'll take a look. Yeah, it looks like it hasn't called our worker. Try shaking the computer. Yeah, thanks, Jonathan. I've heard that does work a lot of the time. So I do have a few moments left, so I'm gonna just double check the processing profile. But you saw how the other one worked, which was kind of cool. So hopefully, if I don't get it to work, I do have an example in another folder of what it would look like. I actually had that on the slide, so we could just take a look at that, but that's kind of cheating. So I'm gonna try to get this to work. Okay. Again, please ask your questions in the chat, as it seems the last few moments will be taken up by me re-examining to see if I did something wrong. Okay, so looks like we do have the right URL for our worker, so that looks good. Did I not apply it to the folder? I don't know. We'll try again. My computer does sound like a vacuum, so that could also be the issue. We're not sure. Okay. Again, I went through a lot of this pretty quickly, especially the code part, but as mentioned before, this code is available online for you to take a look at. So let's see. I'll try reprocessing it again, but I don't know, maybe, oh yeah, it didn't run, okay. Sorry about all the clicking around. Let's reprocess, PDF, okay. 2 minutes left, let's see. But in the meantime, I think I'll just go ahead. So this is what it should look like. And again, I just created this metadata schema, but you can totally adjust it yourself. And this metadata schema is explained in the README of the worker that you can take a look at. So again, it will just sort, it will sort by different, so the keywords, orgs, all the named entities that the API recognizes, that will show up here. So did a pretty good job. There's a lot of stuff to do with mountains as expected. So let's take a look one more time, see if we got lucky, and we'll take a look. All right, so it didn't happen today, but you saw the other worker worked out fine. That's why I did 2 workers in the demo. No, I'm kidding. But looks like there has been an issue, but I think you get the idea of what it would have looked like. Yeah, so this is the last minute of the demo, but I hope you saw just how easy it is just to set up a custom worker using the AIO CLI and then testing and deploying it all pretty easy with not that many lines of code, thanks to a lot of help from Firefly and our Asset Compute SDK. So you can see how you can easily call more complex APIs or other tools and services to expand this to have other image operations done. So it's really simple, easy to use, and yep, I think that is it. So thank you everyone for joining the call. I hope you learned something or found something interesting. So thank you for your time. Bye everyone.